All right, we talk about two complex numbers being real if and only if their real components are equal and their imaginary components are equal. So these two numbers would be equal if A equals C and B equals D. So let's look at how that plays out in an equation. As soon as we see this part, let Z be a complex number. Then what I'm thinking is that my Z can be written in the form A plus BI. So now that means this equation becomes A plus BI times 3 minus I has to equal 1I. So multiplying out, 3A, this is going to be negative BI squared, so that will be plus B. And now I'll look at my imaginary components, minus AI plus 3BI. That has to equal 1I. Well, there is no real component on this side, so the real value must be 0. So 3A plus B must equal 0. My imaginary components must equal 1. Negative A plus 3 equals 1. Sorry, negative A plus 3B equals 1. You could use polysimult or algebra. I already know the answer, so I know that A is negative 1/10 and B is 3/10. In the end, solve for Z. My Z then is negative 1/10 plus 3/10 I. So using this definition of complex number equality allowed me to make my simultaneous equations.